Welcome friends. In our previous lesson, we learned how to derive the basic series form for the function f of x equal to 1 of x. So we are going to use the same example to find the power series form for natural log of x. We found that the power series form for 1 over x is n equal to 0, infinite, -1 to the power n, x minus x less 1 to the power what? To the power n. Now with us knowing this and us having this, we just have to know how to maneuver around. So let me show you one trick, one thing which is known. We know that when you find the derivative of natural log of x, you're going to get 1 over x. Now what this means is when you integrate 1 over x, you're going to get what? Natural log of x. Now what is the power series for 1 over x? The power series for 1 over x is this. So what it means, let me write it down. Power series for 1 over x, the power series for 1 over x. So now for the power series of 1 over x, when you integrate 1 over x, you're going to get natural log of x. So it means when you integrate the power series of x, 1 over x, you're going to get the power series for the natural log of x. So let's just go ahead and integrate it. So now for you to integrate, we are going to maintain this part for numbers, for constants. We are not going to be required to integrate it. So now, how do you integrate x to the power something? You just add 1 to the power, then divide by the new power. So this was x minus 1 to the power n. So we're going to add 1 to the power and divide by the new power. Ladies and gentlemen, here what we have found is the power series representation for natural log of x. You can rewrite it starting n equal to 1. When you want to start your values at n equal to 1, you have to change n here. What do you need to do? You have to replace where there is n, you're going to replace with n minus 1. N minus 1, because n equal to 1, when you subtract 1 both sides, you're going to find n minus 1 is equal to what? To 0. So what it means, where there is n, we're going to be replacing n minus 1 for your function to start at n equal to 1. So this can be rewritten in this form as well. N equal to 1, -1 to the power, where there is n, I'm putting n minus 1, x minus 1, then where there is n, I'm putting what? N minus 1 plus 1, which will cancel. The same thing, n minus 1 plus 1. So the final series, n starts from 1 to infinite, is going to be -1 to the power n minus 1, x minus 1 to the power n divided by n. But now, let it be known whether you're going to use that. For that one, you're going to say n equals to 0. So your first term is when you are substituting 0 for n. For this one, your first term is when you are substituting 1 for n. And you are going to get the same output. Thank you for watching, friends. And if you haven't yet subscribed to the channel, hit that bell icon so that you don't miss out on future endeavors. Bye bye.